So first things first, who are you? What's your role and where do you work?
So I'm Saptarshi Banerjee. I'm a senior solutions architect in AWS, that's Amazon Web Services, and I'm based out of Seattle.
Fantastic. Now, what are three emerging Kubernetes tools that you are keeping an eye on?
Great question. So here are the three Kubernetes tools that I'm watching closely. So first one is Kueue. So it's a job queuing system for Kubernetes, right? Designed for AI ML workloads. It works really well with Kubernetes pipeline version 2 and helps manage GPU scheduling and batch jobs in shared clusters, which is essential as your generative AI workload scales. Second one, Kyverno. So a Kubernetes native policy engine that makes writing and enforcing security and governance policies much simpler than traditional tools like Open Policy Agent. And it perfectly fits into GitOps workflows and helps perform, teams maintain compliance by default. And vCluster, developed by Loft Labs, it lets you create lightweight virtual Kubernetes clusters with a single host cluster. It's great for multi-tenancy, CI/CD isolation, and developer self-service without the overhead of managing multiple, fault clusters or full clusters. And together, these tools are helping teams scale Kubernetes responsibly, securely, and in ways that support, modern generative AI workloads and other workloads as well.
So one of our podcast guests, Mac Jaffe, thinks that you can't just stumble your way into building a secure orchestration system. How do you approach security when designing platform solutions without deep security knowledge?
Right. So you are absolutely right. And this is a very important question. So you can't stumble into building secure orchestration systems. So at AWS, like Amazon Web Services, we treat security as job zero. It's our top priority, right? It's foundational to every platform decision that we make. Now, when I design solution without being a deep security expert, I start by leaning into AWS's built-in security controls. That means like least privileged IAM roles, VPC level isolation, and services like AWS Secrets Manager, KMS for encryption, and CloudTrail for full auditability. All out of the box. And for AI and orchestration workflows, I integrate Amazon Q Developer, right, to catch security issues during development, and use Bedrock guardrails for if you're building, your GenAI workloads, right, to ensure responsible GenAI behavior as well. And for access control, there is Amazon Verified Permissions that helps manage fine-grained authorization at scale without writing complex policy engines. So the key is let AWS or work within Amazon Web Services when we handle, these kind of workloads. We let AWS handle the heavy lifting. Right. So you do not need to be a security engineer. You just need to use secure building tools that blocks and are battle tested. Right. And always involve your security stakeholders early, not at the end.
Well said. Another one of our guests, David, asked, why would you introduce observability tools if observing isn't part of someone's job? Suggesting that many technologies are redundant without operational feedback. How do you ensure observability tools actually serve a purpose in organizations?
Right, and that's a great question again. And I agree completely. Right, so introducing observability tools without feedback loop is like installing security cameras that no one watches. Right. So at AWS, when I work with customers on Kubernetes-based platforms, I always tie observability to a specific operational outcome. So it's not just about metrics; it's about enabling, better decision making. For example, if a team run workloads on Amazon EKS, I help them integrate Amazon CloudWatch Container Insights, right? AWS distro for open telemetry and X-ray, but only when there's a clear purpose. It's like improving deployment reliability and reducing mean time to detect or catching anomalies during scale up. So I always ask the question to myself, who will act on these signals, right? So if no one wants it, it's just noise. That's why I recommend aligning observability tools with runbooks, service level objectives, and incident response, and making it a part of platform teams' KPIs. And also, observability data becomes way more valuable when combined with AI ML services like Amazon DevOps Guru, right, or CloudWatch anomaly detection, which helps surface issues before they impact production. So yes, tools are only useful when paired with operational intent. And my role is to make sure that the intent is clear before anything gets deployed in cloud.
One of our guests, Stefan, thinks that you can't really expect that testing your application in a dev or QA cluster prepares you for production because production is always different. What's your approach to performance testing?
Right, spot on. So absolutely, Dev and Kueue clusters rarely reflect the chaos of production. So the scale, the traffic patterns, and edge case behaviors are fundamentally very different, right? So at AWS, like when I work with customers on Kubernetes platforms, especially with Amazon EKS, the Elastic Kubernetes service that we have within AWS, my approach to performance testing is grounded in realism and iteration. So first, I help them simulate production-like environments using production-grade configurations, same auto-scaling policies, same resource limits, and ideally the same deployment pipeline. So we use tools like Locust, K6 or JMeter, often orchestrated via AWS Fargate, which is a serverless offering, to deploy container workloads, or EKS jobs to stress the system under real world loads, right? Second, we leverage observability to catch bottlenecks. So combining, we talked about a little bit in our previous question as well. So, combining CloudWatch, Container Insights, X-Ray with performance baseline tied to service level objectives. And again, like if you do not measure latency under load, you are just guessing, right? You're just making a mistake. And finally, I encourage, progressive validation, always run state, test and staging, then run canary performance tests in production using feature log flags or traffic mirroring. And then the closest you get to truth without hurting, real users, you are at the right spot, right? So bottom line is, performance testing isn't just a phase, right? It's a continuous feedback loop baked into how you actually release, monitor, and tune in real time.
Kubernetes turned 10 years old last year. What can we expect in the next 10 years to come?
Right. So, Kubernetes has come a long way in the first 10 years, right? From container orchestration to becoming the backbone of modern cloud infrastructure. But in the next 10 years, will be less about managing clusters and more about abstracting them away, right? So I think we will see a shift towards platform engineering and developer experience, where developers will no longer care about nodes or YAML, right? They will just deploy and scale securely using internal platforms. Like think Kubernetes without Kubernetes. Something like, I also expect a lot of AI native platforms to emerge. So as GenAI, LLMs, and agents become central to enterprise applications, Kubernetes will need to evolve with GPU-aware schedulers, dynamic auto scaling, and ML observability baked in, right? And security and policy will go mainstream as well. So, with tools like we talked about, like tools like Kyverno, right? OPA, Sigstore, will help you ensure or enforce compliance automatically across multi-cloud and edge environments. And finally, I think, Kubernetes will power more autonomous and systems at edge, right? From self-driving cars to IoT clusters, orchestrating not just code, but also intelligence, right? So Kubernetes isn't going away, right? It will just become invisible with time behind higher level abstraction that will empower teams to build faster, safer, and smarter applications down the line.
And what's next for you?
Yeah. So, what's next for me is the generative AI and Kubernetes, right? So helping organizations not just adopt generative AI, but do it securely at scale and in production. So at AWS, I'm working with customers who want to move beyond isolated proof of concepts into real world GenAI platforms. And that's where I think Kubernetes still shines. It's the foundation for orchestrating LLM workloads, managing GPU scheduling, and integrating data pipelines, inference layers, and AI agents across the environments. So I see a future where GenAI is agentic, composable and autonomous, and Kubernetes becomes the control plane for all of that. So whether you're running, fine-tuned models with Amazon Bedrock or deploying APIs with Amazon SageMaker, or even using K-Edge native tools like Kueue or Ray, the goal is same, like make GenAI reliable, observable, and cost efficient. And what's next for me is building and evangelizing those GenAI native platforms, right? Combining the intelligence of LLMs and the power and maturity of Kubernetes to help customers ship the next wave of intelligent applications in AWS.
Fantastic. And if people want to get in touch with you, what's the best way to do so?
They can always reach out to me over LinkedIn, and they can always email me as well. My email ID is saptarshi@amazon.com, but LinkedIn would be the preferred way to reach out to me. Yeah. Thank you.
Wonderful. Thank you so much for your time today. Look forward to talking to you in the future. Take care.
Thank you. Thanks, Bart.